move along. One of the main goals of our summit is to bring to your attention innovation and new developments in all things related to food systems. And it is our pleasure to actually turn to one significant technology that is seen as very innovative and has been developed over the last several years, and that is high-pressure processing. Now, Laura before talked about maths. Now we talk about acronyms like PATS, which I don't know if many of you know what it means. I'm sure that Joyce here knows a lot about that. It's pressure-assisted thermal sterilization. So with that, I am going to give a brief introduction to Joyce Longfield, who is a regulatory specialist with hyperbaric, which is one of the leading manufacturers of high-pressure technology in the world. And Joyce has had a lot of regulatory experience, both with hyperbaric and prior to hyperbaric. And she is here to lead us beyond, to take us beyond HPP applications, what it takes to make a high-pressure treated product ready food. And without further ado, please join me in welcoming Joyce.
Good morning. I'm just going to see where it said there's a laser pointer. I just want to see. They're supposed to be, but it's not really. Oh, I see it. Okay. Yep, I see it. Okay. I just wanted to have that because I like to talk with my hands, and so this is going to be an extension of that. So I think, in awareness of time, one of the things that I just wanted to sort of put forth at the beginning of this presentation is when you're developing, sorry, I don't have a mic on, there we go. When you're developing an HPP product, I think the first question you should ask yourself is, why am I using HPP? So what is the goal of it? Is it a shelf life extension? Is it a lethality treatment? Am I achieving a 2-log reduction, a 5-log reduction? And I think if you approach your product development with that question in mind in the beginning, it's going to sort of set the stage for the rest of the ingredients that you bring into it. Okay. So for example, products like these. So, these are essentially raw ingredients, right? They haven't gone through a thermal process at this point in time. So from a regulatory perspective, your goal is going to be a 5-log reduction. You need a lethality treatment to these types of products, right? So from there, now you can determine, all right, so how do I determine that 5-log reduction? And the critical food chemistry factors are going to be the water activity level and the pH are going to be the most important factors for an HPP-treated product. But then at the same time, now you have to look at the ingredients themselves. So, they are essentially still raw. They haven't gone through a thermal process. So they still have active enzymes and proteins. So these active enzymes and proteins really will now start to impact a different type of shelf life with HPP products, which is a sensory shelf life. So if you've looked at or you've assessed what type of microbial shelf life you need, but now as a manufacturer, you have to consider the sensory shelf life based on the organoleptic properties of these products. So as a product developer or manufacturer, you basically have to determine when don't I like the taste of this product anymore to really know what the shelf life of it is going to be. And then your microbial data sort of supports that. It's the secondary component. And in particular, things like proteins, I mean, they can be great. They can create wonderful products like these colostrum beverages. So you get the benefits of the immunoglobulins, but at the same time, you still have all the other enzymes in there as well, which are going to essentially lead to the resulting shelf life of that product. At some point, it's going to no longer taste good. And another example where proteins impact the food itself would be HPP-treated milks. Down here, this is this company in Mexico. So, proteins under HPP can coagulate, so the level of protein content can also impact the overall texture, taste, mouthfeel, and then the amount of fat content in combination with that can also impact it. So a 3% HPP-treated milk is very different than a 1% or a skim milk, which doesn't work out so nicely. So those are things that are probably the most important to consider for raw ingredients, but then also this wonderful little thing of chloroplasts. So chloroplasts tend to impact the sensory shelf life more so than other plastids. They tend to essentially break down a lot faster and then make it taste bad a lot faster as well. Some things that can help hide that or mask it would be obviously increased acid, so lower your pH or increase the amount of sugar, but essentially all you're doing is you're hiding the change in the sensory profile. You're not really slowing down the breakdown of the chlorophyll molecule. Ultimately, what the goal is that HPP is allowing for some unique product development. So we can develop some yogurts that actually use pressure-tolerant lactobacillus cultures, so they can still provide, beneficial probiotics post-HPP without spoiling the product. So that took a long time to design those strains. You can have some functional beverages that you can find at the airport now. And then you can have some antioxidant-rich beverages where this in particular could be very sensitive to if it was thermally processed. But there's lots of different types of products out there with high antioxidant levels that are an HPP-treated product. But I put this one up as an example because, if you are thinking from an ingredient standpoint, one thing in particular with blueberries for some reason compared to other berries, if you were to use the whole berry, it tends to clump during HPP. And we think it's something to do with the pectins because we see it very similarly in different types of tomato products. Some tomatoes, we don't see this problem. Other tomatoes, we do see this problem. But, strawberries, blackberries, we don't see this problem. Blueberries in particular, we do. So this company had to basically make this juice in such a way that you don't have any of those pectins or fibers coming through so that you don't get any of that type of clumping and you just have a very much like a juice product. The other option for HPP would be if you're using it more of a shelf life extension, so not that 5-log lethality step, or you could use it as a post-lethality, so a 2-log. Most of these products, in the case of here, they're already cooked once, so they're using it either as that post-lethality or they're using it as a shelf life extension. I also threw up this picture up here because they're using HPP for shucking or essentially removing the muscle meat from the exoskeleton. And I just think that it's a really interesting way that they use HPP. And it's very different than all the other ways that we're more familiar with using HPP because in particular for this type of process, you have to use a significantly lower pressure than you do for all these other types of products we see on the marketplace. So with a post-lethality or a shelf life extension, if you're using other food chemistry factors like pH to control for your pathogens, you could simply use HPP as a shelf life extension to address your spoilage organisms. I also put up the example of avocados because it kind of goes back to the raw ingredients where we know HPP isn't going to do anything to address the browning enzyme. So if you don't process this product appropriately to remove the air during the blending, then it would still be brown and packaged. So essentially, once you open it over time, it's still going to oxidize and turn brown. Whereas in the case of these types of ready-to-eat products, they're very different than with a raw product because it's a finished cooked product. So how it tastes at the end is how it should taste throughout its shelf life post-HPP. If there's something that is changing in the flavor profile post-HPP, it's probably a good indication that you still had high levels of spoilage organisms going into HPP. Those spoilage organisms are surviving and then producing off flavors that are changing the flavor profile. So, that could be one indication that there's something going on upstream of your process, either in your GMPs or SSOPs, but it could also be an indication of the packaging, which goes into the next portion, and we just heard Laura talk about how important that is. So obviously with HPP, because you're talking about applying pressure to this, uniform pressure, you have to have plastic packaging that has to have 15% flexibility because the water in the HPP unit is compressing by 15%. So you can't, in theory, use glass. There is a company that does use glass. I think they're in Japan, but that's because it's It's a bowl with a flexible film, so that absorbs all of the pressure, and then the bowl itself doesn't collapse. But in most cases, it's just a lot more easier and feasible to use a plastic packaging. And then going back to the whole preventing of oxidation, such as with the guacamole, if they have high oxygen barriers, that's what you want to do, unless you are blending under a vacuum and you can remove the oxygen itself. So some other important things with the packaging. So headspace, not only important, again, to prevent oxidation, but if you have a significant amount of headspace, then you're going to need a wider width on your flange here. And again, going back to that example that I was saying with the bowl, because during pressure, the film is what is going to press down. So the more headspace you have, then the more essentially pull it's going to put on this hermetic seal with the flange. So if you have a very thin lip, but you have a ton of headspace, that's just going to continuously break under HPP. So you have to be very aware of what this relationship is. If you are making a product where there is actually air blended into it, which is often the case with hot dogs, HPP will push out any air in the packaging first, meaning it'll also push out any air in the product. So essentially all of this, what is supposed to be tight packaging around the hot dogs, will become loose, and all the hot dogs will become loose in the bag because now the air is outside of them. If there's air pockets, in the packaging itself, what can occur in these products is that because there's nothing filled inside of it during pressure, it can collapse and then not come back to shape. So if those are just little things to consider, but in this example, it could be rectified depending on the orientation you're putting it into the machine. In this case, nothing really could be done because this is still going to be hollow inside. Rigid packaging, again, this kind of goes more to the amount of flexibility in the package. If it's too rigid, you'll see a lot of stress in the packaging, and it just isn't going to look very appealing to the consumer itself. And again, this could also go back to the relationship between the amount of headspace and then the width of the flange here would be important to consider. And then this is something where kind of leaves off on Laura's conversation. So, if you have a company who is looking for cost savings or is looking for unique design, there could be an opportunity to do something like that with HPP because essentially you are restricted to a cylinder. This will never change. The HPP unit itself will always be a cylinder. So if I just switch over to my next slide really quickly, you can see how, round bottles or square bottles, which we're very traditional, very familiar with, they don't fill up a cylinder very well. But if you are a little bit more, if you play with the geometry a little bit better, then you can find a better fill ratio of that cylinder and then potentially have some unique products. So these two come from examples of some juices that are on the market. This company is out of New Zealand, so they have a triangular shaped bottle. And then this company is out of the UK and they have this hexagon shaped bottle, so when they load it into the HPP machine, they actually do put it in this configuration, very much like a honeycomb, and then slide all of that into the HPP cylinder before going in the machine. And then we have our manufacturing for our HPP equipment is in Spain. We have our Miami office where we have a test kitchen and pilot machine available. So if anybody wants to ever run trials, we do all different types of arrangements with people where they can just ship us down product. We'll run it through the machine. We'll ship it back to them. They can come down, work out of our kitchen, do stuff in real time. Especially in the case of raw foods and raw proteins, a lot of people like to do that because then they can make something, throw it in the machine, and then if they need to change the ratios, they can see everything in real time. And then this is just an example of some of our customers, but they're growing exponentially all the time. This year has been a big surge in HPP products and HPP or companies interested in the technology. We have a great relationship with Wegmans, and so I'm very excited to see what some people want to come up with, and maybe even after leaving this room, we'll see what comes out of it. So I think I have a couple minutes to have questions. And I can go back to any slides if anybody wants me to. Do you want to pick, or do you want me to? Oh, okay. I saw one gentleman in the back.
Are you using CO2 in the process also within the package, anything within the package other than the question?
It depends on the company. Most companies that do some kind of like blended gas packaging are meat companies. That's about it. Yeah.
To what extent are companies concerned about the waste of the packaging at the end of the day? Is there a measure of that? Are companies expressing concern about that?
Because that's fill ratio, that particular thing? Yeah, I think so, definitely. When we first sit down with people and they're trying to figure out, like, okay, this is the way that we currently make it, maybe we'll change it. Obviously, besides the example of juices, pouches are going to fill the carrier the best, right? And to Laura's example as well, pouches are a growing space, right? Everybody seems to be going towards a pouch. So for HPP, it's a great synergy that seems to be happening. Was that what you meant by? Yeah. Any other questions?
Could you just explain what is HPP, or like what is the process of it?
Sure. Sorry, I didn't go into that because I knew I only had like 15 minutes, and I wanted to kind of jump in. But essentially, you have a vessel where those cylinders that I was giving the example of, they're loaded with product. It goes into the vessel. The vessel is closed on both ends, and it fills up with water. Once it's reached its fill capacity, there's pumps that force 15% more water into the vessel. So it's forcing the water to compress by 15%, which is what builds up the pressure. And that's why you need 15% flexibility in the packaging as well. Any other questions?
I had a question about leaseable versus traditional products. Is there a difference in leaseable for 48 hours?
pH, is that what you said? Yeah. So in situ, like the pH has theoretically been tested that it does reduce by one value during HPP, but then it's supposed to come right back post HPP. I think where I've seen a lot of the changes in the products post HPP is a lot of times after the people that are making the products where the pH is more critical are not really allowing for it to come to equilibrium before they test it. And so they make it, they test it, and then they say, okay, I got this pH of 4.6, and that's what it is. But then after you let it sit for some time and really kind of homogenize more and come to equilibrium, then it changes and it fluctuates. And I've gotten emails to that effect, basically, oh, I've measured it pre-HPP and it was this, and then post-HPP it went up to this. What happened under HPP? And it's like, well, how long did you let your product sit before you actually measured your pH? And a lot of times it's, well, I made it and then I took it. So I think that's more of the factor. From the studies we've seen, it shouldn't really impact the pre and the post the way that it does in situ. Yeah.
I guess one of the data is called EPP products and raw products. What organisms are like nutrients are being actually filled between the raw product and nutrition?
We see a lot of stability, right? Especially if it's stored under refrigeration, then we see a lot of retention of the nutrients throughout the shelf life. Obviously, if there's some kind of temperature abuse along the way, that will impact the stability of those nutrients. And every antioxidant is going to be a little bit more sensitive, right? Vitamin C is very sensitive compared to something like vitamin A. So it might have a little bit lower reduction. Again, depending on what is the packaging, what is the light exposure, there's many impacts to there, but also the overall pH, right? Whatever you blend it to at one pH could impact the antioxidant level compared to, a different pH that you blended something to. So there's so many intrinsic factors. It's always very difficult to pinpoint, say, HPP itself did this, caused this change, right?
Could you comment about, I think you said it could be used for yogurt that have probiotics. Mm-hmm. So how do the probiotics survive?
So the example I gave was a company that developed a proprietary vegetative strain of lactobacillus. Because it's a gram-positive bacteria, it inherently has a higher level of pressure tolerance. And so then they just further developed that particular strain to survive the HPP process in high counts to be a beneficial probiotic, but at the same time not spoil the product. So it took them many years to develop that. The most current example that a lot of the companies in North America are using is a lactobacillus strain that, I think it's a lactobacillus strain that is encapsulated. So it's surviving the HPP process and then it's germinating in their gut. Yep.
How does the energy input for the process compare with what would a thermal process?
It is more energy efficient because once it's rise to pressure, then the electrical draw stops, right? It just holds and maintains pressure at that point. So it's not a constant continuous draw like a thermal transprocessing. And the water is recycled up to 90%, so you only lose about 10% water per cycle. Did you have a question?
Yeah, I was wondering, roughly what percentage of the total applications are net right now? And you think that broader applications will be by any one category, regulatory or
So to answer the first part, meat seems like the biggest, but I'd say it's probably equal to the ready-to-eat, like dips and spreads. So between ready-to-eat meats and like guacamole, hummus, salsa, they pretty much share about 60% of the category of the space, maybe a little bit more than that, because it's rapidly growing. But so is the juice sector. You know, in 2012, it might have been maybe about 7%, like worldwide, and probably now it's at least double, if not more, that, especially here in North America, than it is the rest of the world. So from a regulatory perspective, not so much in the U.S., like more so in Canada because we have different regulatory requirements for HPP. It's like Europe where it falls under our novel food sector. So you have to apply for the type of food that you want to be, like that you want to treat by HPP. Once the application is approved, it's public, right? So HPP treated juices are approved in Canada. So anybody now can make and sell an HPP treated juice. Guacamole and salsa are also approved. Hummus isn't. So if you wanted to make an HPP treated hummus, you have to apply for a petition and submit that and get it approved before you can start to sell it. So there would be more limitations, and I think that's why it's been a little bit slower in Canada, because it's a little bit standoffish for a company to want to go through all that investment. They say that it takes about a year to get an application approved. So.
Thank you, Joyce. I think we'll stop there. And